Hi, Plans friends. It is your last math session for the week, so good job. We're doing lesson 32, session 3 on page 721. At the top in the blue, it says finding same area with different perimeters. So that's what we're going to focus on. And as a reminder, I put up here what area is because it has been a while. So area is the length times the width. To find the inside, if you wanted to carpet it or put astroturf down, you need to find the area, so you need to know how much you're covering. The perimeter is when you add all of the sides up together. So if you want to fence it or put a gate around it or something like that. On page 721, it says, Emma drew the rectangle shown. What other rectangles have the same area but different perimeters? So first you have to find out what the area is. And it is like an array. So you're going to count the length and the width. 1, 2, 3, 4. 1, 2, 3, 4. So this shape would have an area of 4 times 4, which is 16. The perimeter is a little bit trickier to find. So this is a perfect square. So we know that it's 4 plus 4 plus 4 plus 4. So you're going to add up all of those, and I'll show you one more time. So you're going to add up 4. You have 4 squares, plus 4, plus 4, plus 4. That is your perimeter. 4, 4, 4, plus 4. You can add these up. 4 plus 4 is 8. 4 plus 4 is 8. 8 plus 8 is 16. You can also do multiplication with 4 groups of 4. 4 times 4 is 16. So that's, again, another way that you can check your work to make sure you're right. So the area is 16. The perimeter, I'll put a P, is also 16. They're asking for, they have the same area but different perimeters. So in the last session, I mentioned how multiplication and division are going to help you. This is where it's going to help you. So the area is 16. They did 4 times 4. So you're also going to figure out what are other factors that get you to 16. That means what can you multiply? These are factors to get you the product of 16. Well, I can do 16 times 1. And I can do 1 times 16. That means I have one group of 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15. Okay, this one would be the opposite. It would be 16 groups of 1. So these will have the same area, which means if I do 1 times 16, I get 16, but the perimeter is different. The perimeter for this one, let's just go with this one for example, the perimeter is 16 plus 16 plus 1 plus 1. So it's 16 times 2 and 1 times 2. Anything multiplied by 1 is going to be that factor. So 2 times 1 is 2. 16 times 2 is 16 plus 16, which is 32. 32 plus 2 is 34. So I have a much different perimeter. I had 16 and now I have 34. However, my area still is the same. 16 by 1, I have 16 blocks in that. So that would be an example of other rectangles that have the same area but a different perimeter. When you turn the page on 722, it gives an example. You can use drawings to help you find rectangles with the same area and different perimeters. The area of Emma's rectangle is 16 square units. Below are 2 other rectangles that also have an area of 16 square units. This looks like what we did. You can also put it back up and it's 16 groups of 1. This is another one. You can also turn these rectangles on their sides to get 2 more rectangles, like I just said. Here is an example. 16 times 1 is 16. The perimeter's 34. That's what we just did. 8 times 2 is 16. And the perimeter's 20 units. 4 times 4 is 16. And the perimeter is 16 units. So all of these different ways to find the area of 16, but yet they have a different perimeter. These are all factors of 16. That means I can multiply 16 by 1 and get 16. 8 times 2 is 16. 4 times 4 is 16. That is going to help you out for the rest of this lesson. On page 723, look at picture it. How can you tell the two rectangles shown have the same area as Emma's rectangle? Well, you can count the squares to see that they have an area of 16. There's really not a whole lot more to it. So these rectangles, you can count them. So that's what you would do. You'd count to see that there's one group of 16. Here there's two groups of 8. So the answer for, I'll keep that up there. The answer for number 1 is to count the squares. That's how you're going to find the area in those different shapes. You can count the squares to find the area of 16. Number 2. To find other rectangles with an area of 16 square units, think of multiplication facts with a product of 16. What are the multiplication facts that have a product of 16? So that means when you multiply two numbers, what would equal 16 when you multiply them together? I gave you a couple. We did, the first one is 4 times 4 equals 16. That one, no matter how you flip it, it's still going to be the same. So there's nothing else I can do with that. I did 16 times 1. You can flip that like we had. 1 times 16 is 16. 8 times 2 is 16. 2 times 8 is 16. So all of those are different. So 8 groups of 2, 2 groups of 8. Look at the table and model it. Where do you see the factors and products of the multiplication facts that you wrote? So the factors are the length and the width, and then the product is the area. So again, 16 times 1, these are the factors. Length and width are the factors. You're multiplying those to find the product, which is the area. So the second part of number 2 is that the length and width are the factors. The area is the product. Number 3. How can two rectangles have the same area but have different perimeters? So rectangles have different side lengths that can be multiplied to make the same area, but add up to a different perimeter. So I'll put something about that. Rectangles and widths that multiply give you the area, but add up differently. So I really like that 16 by 1 examples. When you did the 4 by 4, 4 and 4, when you multiplied it, you get the area of 16. But then when you add it up, you do 4 plus 4 plus 4 plus 4. and the perimeter is 16. However, when I did this way, this is 16, this is 16, 1 and 1. So I have to add up all those. I still have 16 blocks. It's just going on the outside. So 16 is the area, but the perimeter was 34 because I'm laying it out instead of scrunching it up. And number 4 is reflect. And this is again where you get to choose what works better for you. Are you finding it easier to use a model or maybe equations like this? So you're just going to write model or equations for your strategies. Now, if you turn the page to 724, problem number 5, look at the rectangle shown. Draw a rectangle that has the same area but a different perimeter. So with that, we have to find the area first to figure out a solution to this problem. So area is length times width. So the first thing you're going to do is count up how many squares make up the length and how many make up the width. That's your very first step if you want to find the difference. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll put that second because it's groups of 9 and it's 1, 2. So 2 groups of 9 is 18. So now draw a rectangle that has the same area but a different perimeter. So I also have to find out the perimeter. So that's the area. Now I'm going to draw a picture. 2, 2, 9, and 9. So that's the area, 2 times 9. But now I'm doing the perimeter, so I'm going to add all of these up. A shortcut for adding these up is multiplication. I have 2 groups of 2. 2 times 2 is 4. I have 2 groups of 9. 2 groups of 9, which is 18. 18 plus 4 is 22. So now I know that I need to find factors or multiples of 18. So I can't do 9 times 2 because I'll get the same perimeter. It's just tilted over on its side. So I need to think of other factors of 18. The first one that comes to my mind is 6 times 3. So if I have my blocks like this, there's a 6 and this is 3, 6 and 3 because it's a rectangle. Opposite sides are the same length. I know 6 times 3 is my area and that's 18. So my area matches, but my perimeter is going to be different. It's going to be 6 times 2, or I'll do 2 groups of 6 and 2 groups of 3. So 2 groups of 6 is 12, 2 groups of 3 is 6. 6 plus 12 is 18. Now this perimeter is bigger. I need more fencing. So that is the same area, but a different perimeter. You could come up with another factor of 18 would be 1 times 18. So the area is 18, but the perimeter is going to look a lot different. 18, 18, and 1. So 2 groups of 18, 2 groups of 1. Let's see, this is 34. So it would be 36. Way different. Okay, that's just another example for you. Number 6 says, look at the rectangle you drew for problem number 5. Is its perimeter the same as, greater than, or less than the perimeter of the original rectangle? So the perimeter of the original one was 22. My second one was 18. So I would write less than. The perimeter was less than. However, this one was greater than by a lot. Okay. Okay, last one until we're on to the additional support pages. Number 7, Joel plans to start a rectangular garden like the one shown. He wants to put fencing around his garden, but he only has 20 feet of fencing. Using the same area as this garden, what side lengths could his garden have so it has a perimeter of 20 feet? Show your work. He wants to put fencing around his garden, but he only has 20 feet of fencing. Using the same area as this garden, so you need to figure out what the area is of this garden. They give us the length and the width, which is 3 by 8, 3 by 8, and 3 times 8 is 24. So the area is 24. So now that you know the area, you need to find factors of that to be able to find the perimeter. So 24 could also be 12 times 2. So 12 times 2 would look like 2, 12, 12, and 2. He has 20 feet of fencing using the same area as his garden. It's going to have a perimeter of 20 feet. I need to find the perimeter of 20 feet. I can tell automatically this is not going to be that. So 12 plus 12 is 24, plus 4 is 28. So this is a 28 perimeter. This one will not work. So let's see. All right. Another solution that I could do is just as an example, I know 24, oops. 24 times 1 would give me the area of 24. However, this is going to be a greater perimeter because at 24 plus 1 plus 1. 24 plus 24 is 48. Plus 1 is 49, 50. So my perimeter would be 50. That's not going to work. I need to get 20 because I only have 20 feet of fencing. Another multiples that equal 24 is 6 times 4. So I would have that. And I would do 6, 4, and 4. 4 times 2 is 8. 6 times 2 is 12. 12 plus 8 is 20. So his garden needs to be 6 feet by 4 feet. So I use the process of elimination. All of these, when I multiply the length times the width, equal the area. However, when you add up the perimeters, you get different numbers. Next is page 725. Number 1, both rectangles on the right have an area of 12 square units. Write the perimeter of each in the table. So the perimeter, if you know the sides are 6 and 2, for example, for the first one, then you know the other sides that are not there are also 6 and 2. So I'll go ahead and write that down. Okay. Okay. So for the first one, it is 6 and 2. So 6 times 2 is 12. So that's the area. This side we know is 6, and this side we know is 2. But I do think it's helpful if I draw it for you. So 6 and 6 and 2 and 2. So it would be 6 times 2 and 2 times 2, which is 4, and 12. 12 plus 4 is 16. So the perimeter of that one is going to be 16. So you would write that in that top box. And then you have 3 and 4. So it would be 2 groups of 4 is 8. 2 groups of 3 is 6. 8 plus 6 is 14. So in that second box down, in the second row, you're going to write 14 units. Number 2, draw 2 different rectangles that have an area of 10 square units. Write the number of units for each length, width, and perimeter. Well, there's only a couple of factors that would get you to 10, so that's kind of a clue. It says length, width, and then perimeter. So you're trying to get to 10. So what you're looking for is factors that would equal 10. I know 1 times 10, and I know 2 times 5. So you can write in either one. So the first one, let's just do 1 length, 10 width. The perimeter is going to be 10 plus 10 plus 1 plus 1. So 10 plus 10 is 20, 21, 22. 22 perimeter. Number 2 is 2 length, 5 width. Now this one's a little bit different. 2, 2, 5, 5. 5 plus 5 is 10. 2 plus 2 is 4. The perimeter is 14. So that's what you would write on these lines down here. 1 times 10 and 2 times 5. When you are done with that, please turn the page to number 3. Simone has 16 square inch tiles. She glues all of them onto cardboard to make 2 different rectangles, each with the same area. So again, you're looking for factors that would equal 16. What are the side lengths of 2 rectangles she can make? Something that is super easy that I hope you're noticing is that you can always do 1 and then times it by the area. So she has 16 tiles. You can do 16 times 1, 1 times 16. So that would be one that is very easy. So if it is hard for you to figure out what you can multiply together to get to 16, know that you can always do 1 times your product or your end number for that area that you're looking for, and you will have one of the solutions. So she has 16 square tiles. She wants to know the two different perimeters. So the area is 16, but we need 2 different perimeters. This will be number 1, and this will be number 2. So as I mentioned, you can always do 1 times 16. That'll get you an area of 16. Length times width. So here we go. 16, 16, 1, and 1. 16 plus 16 is 32. 1 plus 1 is 2. 32 plus 2 is 34. That's the perimeter of this shape. Another factor of 16, or 2 factors, is 2 times 8. That will give you an area of 16. It changes a little bit. So this is 2, 2, 8, and 8. 8 plus 8 is 16. 2 plus 2 is 4. 16 plus 4 is 20. So here we just found 2 different ways to find a different perimeter with the same area. Number 4, Simone wants to glue colored string around the edges of the 2 rectangles she made in problem 3. What is the total length of string she needs for each rectangle? Show your work. So the total length of string is the perimeter that we just found. So she would need, they're inches, they're square inches. So for this one, she would need 34 square inches, and this one she would need 20 square inches. This one has a greater perimeter. This one has a smaller perimeter. Number 5, Enrique draws a rectangle at the right. Draw another rectangle with the same area but a different perimeter. Which rectangle has a greater perimeter? Again, if you're going to compare, then you first need to figure out what this one is. So we're going to find the length and the width. 1, 2, 3, 4. So it's 4 groups of 1, 2, 3, 4, 5. 5. 4 times 5 is 20. That is the area. So I needed to find something that has draw another rectangle with the same area but a different perimeter. So now I'm looking for what other factors besides 4 times 5 will get me to 20. 2 times 10, 1 times 20. Those are different options that you have. So let's go with 2 times 10. I know my area is going to be the same, because 20 is equal to 2 times 10. However, I don't know what my perimeter is going to be. 10 times 2 is 20. 2 times 2 is 4. So my perimeter is 24. You can add this up, you can multiply, whatever is easiest for you. So now I have a perimeter of 24 with this shape. I did something wrong though. I found the area of the first shape, but I didn't find the perimeter. I'm assuming it's the same, but let's do it just in case. 4 and 4, 5 and 5. 5 plus 5 is 10. 4 plus 4 is 8. 10 plus 8 is 18. That's the perimeter of the original shape. So this one has an area of 20, a perimeter of 18. My new shape is 2 times 10 equals 20, same area, different perimeter, 2 rows of 10. So it'll look like this. And my perimeter is 24. And then it says, which rectangle has the greater perimeter? This one is greater. It 24 is more than 18. So good job, you're done with math for the week. I'm super proud of you. Keep it up. You have one more week of school. You got this.